on the entire time. There we go. All right, that's all right. This is a bonus lecture anyway, and oh, we do have 3 people watching. Sorry for those at home. I screwed this up. Anyway, I was talking about the network transport layer security and stuff like that. What I'm about to do is I'm about to open up a connection on the transport layer using Telnet. I'm going to connect to the CSE server, and I'm going to send an email. Okay, so let me go ahead and connect now. Right, the server is sitting there waiting for a protocol. Right, remember a protocol is a prescribed way of communicating back and forth. Yep. Okay. Good. We're good now. Sorry about that. I usually check that right away. All right. Thanks. Anyway, I'm going to send an email now, and it's just waiting for me. If I just start mashing the keyboard, how are you doing? All right. And it's what? What are you talking about? Right? Because there's a prescribed protocol here for sending email. That prescribed protocol begins with a back and forth. For example, I need to say hello. Right? Literally, I need to say hello. This is part of the protocol. And it's HELO, not HELLO, because all of the most of the protocol commands are four letters. Hello, cse.unl.edu. Oh, pleased to meet you. Right? It's a back and forth here. So I want to send some mail. The next thing I need to do is say who the mail is from. Right? And it's from me@foo.com. Right? There we go. Okay. Now, is that an actual sender? No, but that's part of the protocol. The protocol does not dictate that the sender actually has to exist. Right? Errors can occur if this is an invalid sender, or to prevent spam, you can check to see should I be sending this on or not. Right? We'll find out that the CSE server is not checking for this kind of stuff. All right, so that's from who it's from. Our receipt to. Let's go to me, cburke@cse.unl.edu. Right. Actually, no. Let's go with my Gmail address at gmail.com. There we go. Okay. Right. And now I need to specify the body or the data of the email and the body. So I'm going to go with data. Right. Okay. I'm receiving data now. Because if I had multiple people that I wanted to send it to, I could go receipt to this person, receipt to this person, receipt to this person, CC, blind carbon copy, et cetera, et cetera. So it's going to be from, let's see, yeah, me. Who am I? Me@foo.com. There we go. Who's it going to go to? Well, it's going to go to Chris, cmburke@gmail.com. Right? This is metadata. And what is the date? Today, right? Of course, I could have formatted this date. They're just strings anyway. Subject, right? How are you doing? Right? All right, there we go. And then I have the actual message body here. Good to meet you. All right? And like it said, how do I end this all? With a period by itself. Message accepted for delivery. Right? Now, it's still sitting there waiting for me to give it more, because if I've got another email to send, of course, it's going to sit there nicely and wait. I'm going to go ahead and close the connection, though, interrupt the connection here, and just simply, oh, no, that's not part of the protocol. The part of the protocol is quit. Right, there we go. Okay, goodbye. It didn't say goodbye. Sometimes it says goodbye, but whatever. So let's go over here to my email client. Refresh. Hey, good to meet you. There, it was sent by CSE. It's from me@foo.com. Obviously, that's not from who it's from. I can look at the entire original. Let's see, where's the show original here? Now, a lot more stuff came along the wire that I didn't put in there, that the server put its own metadata in. And you can see all that stuff here. Barracuda, for example, is CSE's spam filter. Wow, I'm amazed, and I tried this before I came here, so I was amazed then too, but I'm amazed that Google is allowing this email to be sent. So cse.unl.edu must be a trusted server. So as long as it's trusted, you could go ahead and start bouncing spam off of it, and you're good to go, right? But anyway, that is a protocol, that back and forth, that I had to say hello first, because if I didn't say hello first and identify who I was trying to contact, then it would say, I don't know, nope, you're not speaking my language, right? Another protocol is the Hypertext transfer protocol. Right? This was just an example of the back and forth using Telnet. The HTTP protocol standard is now well over 30 years old, right? It is a client-server model, so the client makes a connection to the server and requests resources, or gives it, makes a post and sends data back and forth. The example I just showed you was sending email. But HTTP protocol is the protocol for the web, right? It stands for Hypertext Transfer Protocol. It has a long history. It was invented or created by Tim Berners-Lee, a very famous name. He also came up with HTML. The first version was in the early 90s, and it's been updated since then. Now, 1.1 stood for nearly, 20 years before somebody finally came along and said, look, this web thing is not is not going away. We need better standards. We need a faster way of transmitting stuff. And so version 2.0 came out just 6 years ago. I looked it up, and it's still only 47% adopted by the top websites. So the even the majority, the good majority, are still on 90s protocols. Why? Because it works. Right? It's tried. It's true. It was a good standard. So if it ain't broke, why fix it? Why change it is because you want things to be faster. Not only do we have 2.0, but 3.0 was introduced. It's still under draft. I looked this up before I came. It's still under draft. It's not an official standard yet, but something like 70% of web browser users actually support it. This one was put forth by Google. It was originally called Quick. Basically, it cuts down on a lot of the handshake. The protocol, if you have to go back and forth 20 times, the idea here is that it cuts it in half so that you only have to go back and forth 10 times. It's not really making networks faster or anything. It's just cutting down on the overhead. Yeah?
Isn't there like an HTML5 thing?
That's HTML. The HTML5, it's different from the transport protocol. It's how documents are actually marked up and formatted. But yes, HTML5 is on 5. I don't think there's anything since then, just maybe addendums or something like that. But yeah, we're talking about just the transfer protocol. How does this stuff get from your computer over the network to another computer, or vice versa, whatever it doesn't really matter who the server and the client are. Sometimes the actual box can be the server versus a client. It's all a matter of perspective. All right. So HTTP lives in the application layer under this OSI model. It lives up here, or in the TCP/IP model, it lives up here. What I just showed you with SMTP was a transport layer protocol, because I actually had to open up a socket to a particular port. Up here, you don't do that. You do eventually have to go down to the transport layer, but it is an application layer protocol. Right? So what does it look like? Well, a client makes a request to a website, specifying a method. How are you requesting this? A resource. What do you want? And then it is required to specify which HTTP version should we be talking back and forth on. Are we speaking version 1.1? Are we speaking 1.1 because we, or 2.0 or whatever, because we need a common language? And if you're using an old protocol and I'm using a different protocol, we're not going to be able to communicate back and forth. Also, a client may send any number of headers. This is additional metadata. Who it's from. By the way, I'm using Firefox, right? That's the kind of metadata that would be sent back and forth. I live in Lincoln, Nebraska, and my time zone is Central Standard Time, right? All that kind of stuff is metadata that the server might find useful. Who knows, right? They might not. It might end up, ignoring it entirely. Then you send a blank line. Then you send the request body, anything that any additional metadata. Then there are 2 blank lines, and all of your lines must end with this traditional Windows endline character. CRLFs is what we call them. This is a carriage return. This is a line feed. That's what CRLF stands for. That's just a technical issue that we won't have to deal with because that's the default with Telnet. Okay? And then the server responds with any number of response codes. Anything that begins with a 1 is just informational. Anything that begins with the number 2 is thumbs up, good, accept, right? The most common one is going to be 200 success. You asked for this photograph or this JPEG image that was stored in the server. Okay, here you go, 200. 200, yes, it was successful. And by the way, here's your data, right? Redirections, we're no longer there. For example, our old website was cse.unl.edu. What is our new website? computing.unl.edu, right? The server is still CSE, by the way, and we're going to play with that. But otherwise, you also have 404s, for example, not found. If you go to a website, a valid web address, but an invalid web page, then you get a 404. Or 403, forbidden. You're not allowed to, it exists, but you're not allowed to see it, right? 451 is a very interesting one. It's a canary in a coal mine, right? You know, why is it 451? Think of a book named 451. Fahrenheit 451. Not exactly about censorship, but this is 451 is what this is about. It's been censored. It's a signal to you that some government agency, foreign or domestic, whatever, has made this resource unavailable due to censorship legal reasons, right? Or 500 internal server error, 503 service not available, etc. Right? So these are all the response codes that you could get back from the server. Right? There are several methods. You can get a resource. You can post. I intend to send data to be written to a database or to be processed so that you can give me some sort of a response. Others that we're not going to go over are put, delete, trace, options, connect, path, etc. This all goes into what are called the Restful Services. REST is representative state transfer, right? So basically, the four basic things that you can do with data. If you've got this collection of data, you can put stuff in, you can post stuff, you can get stuff out, get, you can delete stuff, delete, right? And you can modify stuff. What would that'd probably be a put, right? That's what I would put that under, maybe, right? But in any case, this is a protocol. It's a robust protocol that was designed originally basically to do anything that you would want to do in the future. None of this stuff has changed, by the way, in the 30 plus years, because it hasn't had to change, because we've got plenty it was well designed to begin with. Certain things like additional error codes have been added later on, but the protocol itself, using these response codes and methods, has not changed for 30 years. Right? So let's see it in action. I'm going to open up another Telnet socket to the CSE server, but I'm going to talk on a different port. The standard port for HTTP is, does anybody know? Off the top of their head? No? 80, right? So let me go ahead. So if I just, say, give me your web page, please, right? So what the hell are you talking about, right? And it actually responded with a bunch of stuff. It responded with a bad request, right? 400. That falls under error codes, client errors. You gave me a badly formatted request because I didn't say get a resource. I didn't specify the HTTP version, et cetera, et cetera. So it just simply says bad request. And also it sends a body so that if you're doing this through a web browser, what happens? You get this HTML that is going to be formatted and says your browser or proxy sent a request that I could not understand, the server could not understand, et cetera. Right? We're running Apache 2443. Right? So let's actually have a valid request. That valid request is going to go to this website. Right? Look familiar? If you put in a name and a birth date, I was not born, that's in the future. All right. That's not my birth date, but just a random date. And submit it, right? I get it back a response. Let's do that same thing, or a similar thing at least, by starting out here. Right? I want to get this URL right here. All right, so what I'm going to do is I'm going to go ahead and open it up back up to 80. And I've got to be quick about this because it's not going to sit there and waste network resources if I'm not, quickly asking for something. So I'm going to say get this thing, and what version of HTTP should I use? HTTP 1.1, and this is required of 1.1 CSE.un. That's the only required header. Once I do that, I get a response back. Right? So I typed quickly enough. Right? Eventually, it's going to time out here. It is still waiting for any further requests that I have to go back and forth. But otherwise, I fulfilled the protocol, and there we go. And it successfully gave me that web page. Right? So all it is raw HTML. If I look at this and look at the page source, look familiar? It's exactly what this is right here. Right? Except for at the end and for at the beginning. These are headers. This is additional metadata that the server sent back to me. For example, a date, a timestamp. It told me what a server it's using. It's using an Apache web server version 2.4.3. It's powered by, hey, looky there. That's the PHP version that we've been using this entire time, right? What else? Powered by Mono. I'm not sure what that is. But otherwise, it's accepting anything that is Unicode encoded, so UTF-8, right? Bunch of other stuff here. Same origin policy, no sniff. That might be like a tracker information. It's promising that it's not tracking us, maybe. I doubt that, but whatever. All right. Anyway, you can see the same thing on a browser end. All you have to do is enable, oops, not settings, tools. Where are other tools? More tools. There we go. Web developer tools. Right. So let me go ahead and refresh this and take a look at the network here. What happens? Right. There we go. Let's take a look at this actual jQuery PHP right here. Don't double click. We can get rid of that now. Get rid of that, and we'll come back to that in a moment. There's our source. But otherwise, do you see all that stuff right there? Right. It's the same it's similar headers as was sent over here. But there's a lot more. For example, there's cookies. There's a cookie that's a session tracker if I'm logged in or anything like that. But a lot more headers over here because Firefox formed this request and sent it on. Firefox was sending a lot more metadata. In fact, it was sending all of this stuff right here. None of this stuff I ever sent. Right? So you can get extremely sophisticated with this and send back and forth metadata all day long, etc. You can have full applications built around this protocol, RESTful APIs, RESTful applications. Let's take a look at what happens when I actually hit submit here. All right. There we go. And let's take a look at this post. I don't want that. Let's take a look at this post. And let's look at the, where's the raw? There we go, raw. Right. There is the raw request. There's request. Where's the body? There we go. I want the actual body. That's the response headers, request headers here. Let's look at the raw here.